If there's one collective challenge that we as the human race have, right? The one thing that if we could just beat, it would be cancer. We're so terrified of this word, cancer. And if we're able to, one, understand it better, and two, know, okay, oh, great, this is what's coming. This is how it's going to make sense. This is how we win this battle. That's going to feel amazing. And I'm so excited to have this podcast to give you information so that all of us know what's ahead and can really help that vehicle move forward. Now, it would not be right if I did not introduce the man that made all of this happen and kind of whose job I basically took, Mr. Mika Newton, who is doing exactly what we're talking about in cancer, almost in a philanthropic way. I believe you were retired, right? And then you were like, I want to do one more thing to help people around the world.
Your taking over is the best thing that I could possibly imagine happening to this show and everything that we're doing. So what was going on in my life at the time was I had been working for many years with biopharmaceutical companies on data and technology, and actually working with government agencies too, and other nonprofits. But everything I was doing was really, or felt like really far away from what really mattered, which was patients. And I started to experience that firsthand myself because my dad passed away really suddenly, a complication related to cancer. And I ended up as a caregiver for my mom. She suffered from dementia, and then we found out that she had cancer. And I was just like, how can this be happening? And how could I have worked on all these things, but not be doing something that even I could use myself? Like when I needed to figure out what to do, I didn't know, I couldn't find any way to help. And so I thought, oh my gosh, I got to go off and do this thing and do something that really matters. And in the process of doing that, I met a guy, actually, his name is Marty Tenenbaum. Marty is like one of the original AI pioneers in all of Silicon Valley, really, and he's a cancer survivor. And I started collaborating with him, and then a lot of this story that became the company xCures started. So that was over 3 years ago, and we set out to do really one thing, which is figure out how to help understand what's happening to people who have cancer, what they should or shouldn't be thinking about doing, and most importantly, just like what's working and what's not working. It's like such a simple question, right? Like, what's going on with other people like me, and is it good or not? Because I want to do the good things, not the good things.
That's a good point. You bring up a good point is and you're an example of that, where people may ask, okay, we know so much with technology. Like, as I mentioned at the beginning of this, there's just so much going on. How come we're still using stuff from 25 years ago that we know exist and are coming out supposedly every day? So much research in cancer. You worked in one part of the world, or the concept of cancer care, and people are doing that every day. But there's a transition or a translation of all this crazy novel stuff that's happening actually being adopted into practice. And it's not like a resistance. It's not like, they're just, people aren't taking the time. That's a humongous bridge that is very concerning, because at one layer, and that's the whole purpose of this podcast, all of these things are happening that are so novel and so revolutionary, and not the way cancer was treated like we think about it and is still treated. But then there's this other side of what's happening in the everyday world. And so you were part of that, that novel world, and still are, but you got to see it as a patient as well and say, okay, but how do we bring, I know what's going on in the world. How do I bring that into the care for my mother and the people that I know? And that's a challenge. And it's things like this where everyone is listening now is going to be, at the dinner table. And if you want to hope that somebody brings up cancer, because you're just going to put your drink down, put a smile on your face, and lean back and say, aha, so what do you know? Because this is what I know, right? And that's why, that's what's brought you, and that's I think the coolest thing, and maybe it's celestial orchestration on what you're bringing. You took artificial intelligence, right, and all of your experiences in that industry to benefit us in the real world in real time, like treatment and management of cancer. And what does that look like, and what are you trying to achieve?
You bring up a great point. This has been done so many times in so many other places before. Like I grew up in a world, and you're huge in the social media world. Social media didn't exist when I was growing up. Like I didn't even have a cell phone, right? When I started. So all of this new stuff, and it came really, really fast. But then when you start looking at medicine and healthcare, it suddenly feels really, really slow for when you're a patient. And then, but you read, like you're talking about the artificial kidney, like you go online and you read about these great, new discoveries, and they're doing this and that. And you end up with this sense of like, am I missing something, right?
Is it
Like,
another
how
world? Yeah, like,
is
is
it
it just
like
happening, but not here in this world?
not here in this world? And so part of what happens here, and I think this is a piece that most people don't realize, the path from like a new idea in healthcare to when it's like in everyday use is like a really long process. And it's long for good reasons and for some reasons that are challenges to overcome. It's good because, you know, when we go and get care, we want to know that it works, right? And that it's safe.
Right. So that is one big element. It's like, and maybe at some point we'll talk about it in a more exciting fashion. Why do we know it's safe? How can we say it's safe? And all the, very exhaustive, time and things that happen to make sure that people pertaining exactly like you, if you're going to get this treatment for your thing, do we have 100 other people like you for your disease process that experience this? And what is that? So that's one part of it. And then what's the other part?
The other part is we want to make sure that it is really going to work. Like, it's going to be safe and it's got to be effective. So
Right.
there's the time part. The not so great part about it, right, is that we require like a very high level of evidence and proof, right, which is good, but it's hard to do. So the numbers are difficult. Let me give you a good example. So we just saw an amazing miracle with vaccines for the pandemic, right?
Right.
This is technology, frankly, that was being developed for cancer care in some ways, and has been in that space for. And suddenly there was COVID, and we mobilized clinical trials and thousands of people in those clinical trials, and within a very short period of time, within like a year, we have vaccines. That blew people's minds. When we started on that project, everybody was like, that'll never happen. It's not going to pan out. But it did, and it moved really fast. It was incredible, but it has some characteristics, right? Everybody was getting basically the same disease. Like, I know there's different variants, right? But everybody was getting the same thing. And then we were testing. We had a lot of different things we were going to test, but there were so many people getting that same disease at the same time. And I mean, this as an oncologist, when people get cancer, it's like everybody's own individual disease, right? Like, every single person is different. So it isn't one disease. We group them together, group cancer together in a certain, whatever organ it started in, but it actually could be as individual as you and I are different. So how do you do that? And then it's not like we have even 10 things or something. There are, I think last time I looked, over 1,000 different new technologies in development in cancer today. And there's already 1,000 that already exist. And we know that we don't use them one at a time, right? We use them in combinations with each other and in different orders. And so that problem of like, how do you test all those different things that's where things like AI and search, and I think that's going to really change the world here.
And I think I want everyone to understand this, and you touched on it. But the tricky thing about cancer is, have you ever bought a house and you see like, the switch circuit board, right? Mm-hmm. And they're not labeled, and that's really annoying. And you don't want to have to reset your routers and log into your Netflix and all this stuff all over again if you knock all of them down. But that's what cancer is. So you could have like a house and you could say, okay, this is a residential house. This is colon cancer. This is a office space. This is breast cancer. So like, I have an idea of like what the climate of that place looks like. And obviously if one place is an office that has, a bunch of computers and all that it has some features that put it all the same. But when you go into those circuit boards, colon cancer, breast cancer, lung cancer, they all, like, you don't know what, imagine 1,000 switches and all of them. You don't know which ones were flipped in that colon cancer versus somebody else's. And if that isn't hard enough to conceive, like, there's no fingerprint until recently, and we're going to talk about that, on where you could say, this is the mechanism. This is the one circuit switch that was like flipped, and therefore it's no longer being, like regulated in your body and it's turned into a cancer. What people don't appreciate is, once you start giving therapy and you do that, what's called selection pressure, you're like putting stress on the cancer cell. That cell at some point of that therapy is going to just basically say, I don't need this switch anymore. And it's going to flip another one. And suddenly this other switch that, if we're lucky, we even know exists, then is the reason that this cancer cell is still able to grow and divide. So that's the progression. So people are like, oh, I had a good response to my chemo, but then it just went through. It didn't cure it. Yes, it killed all that population until another switch on the circuit board, and you have to start all over. And then how do you predict which one in you versus me is going to be switched? And I think that's that concept. If you're listening to this, that's what makes difficult using the word a silver bullet or the cure for cancer. They're all different houses and different circuit boards in each one. And during the very process of treatment initiation, some other switches are going to be flipped. And then I was having a conversation with somebody, and this is this is what this podcast is about. It's like, we used to do this shotgun approach. Like, let's just, if there's mold in a building, let's just give a whole bunch of anti-mold stuff and say, y'all, don't go into that house for, a week, and then otherwise it'll kill you. So the problem is with chemos, they all do poison your cells. You can't leave your body and just say, hey, let's just blast it with some, poison chemotherapy and then you return. You're actually part of it. So you can only give the body how much you can tolerate with your good cells while hoping to kill the fastest ones, which are cancer cells. Now, these switches, instead of just putting it through the ventilating system in the house, which is basically a shotgun approach, we're actually targeting switches. And that is targeted and molecular therapy and precision medicine, where we can say, I don't have to just use a general, antifungal or attack the whole house. I need to figure out which switch, and then I'm going to go find it. And that's when people say, oh, this new stuff in cancer, that's it. But can you imagine, with the amount of things that are coming out in this tech world, like, are people aware? Are oncologists aware? There's no bigger fear than waking up at 2 a.m. and when you had a conversation with a family, you have to look at them and say, there are no more promising available options, and this is kind of like hospice or palliative care. In reality, there very well could be something that exists that you don't know about because it's not approved, but it actually could give them another 8 to 12 months, right? And that is a very stressful thing. And that, I think, at the bare minimum, is where AI comes in, because a human only has so much bandwidth to look at every current clinical trial, the data, everything as it comes out every day and every week. AI technology can do that for you. How does that apply to your thinking? And this obviously is in question.
I mean, you just described exactly the kind of conundrum, right? If everybody's different, what do I do? And if I have thousands of different tools, how do I even keep in my mind, like going in that toolbox, like, and finding what's in the toolbox? Somebody's got to help me select the right tools. And so we came at this problem kind of thinking of two things. Number one, right? How do you make a catalog? Like, somebody's got to keep track of everything, right? And we want to do that. All of us want to do that in a way that it's like well organized, like,
Right.
Like anyone would have a listing on Yelp. So we've got to manage this catalog of all these things. And then we have to have information about it. So the one thing we kind of learned, and my team learned, is you actually have to think about clinical and biological rationale. So we were talking to oncologists and doctors, and they're like, well, when I look at a patient, I look at two things, right? I look at how are they, right? To your point about, like, are they going to be able to tolerate something? Are they doing well? Do they look healthy, right? Do they seem like they feel strong? Are they telling me that they're willing to, or look like they could tolerate this thing, because it's going to be, physically difficult.
Right.
So that's one element. And then also other things like, have you had a surgery before? Like, maybe you had some sort of surgery or some other disease that took place, right, that you've had or have as a chronic illness. That could change everything about you. And then the other thing we realized is there's this biology. So those switches that you were talking about, right?
Right.
Like, how do we understand those? And there's an incredible number of companies out there who are developing basically the mapping technology, sequencing technology. These are all the switches in the direction they're in today. And then another set of companies that are like, hey, you've had some treatment, here's the new set of switches. So I think we've identified over 10,000 different things that people are thinking about doing in cancer. And those things are like multiple combinations of things, right, in different order. And so we want to take what we know about a patient, right, and present to their physician, doctor, and say, here's what we think we know about your patient based on everything we understand about them. And then here are the things we think you might want to know about, right? And you may want to actually consider and start researching a little bit deeper, because then you don't have to go look at those 10,000 things. And then the last piece, and this ended up being, when we started this 3 years ago, it was like a huge aha moment for me, which is the how do you get it? Access becomes really important. And in healthcare, I've been through this in my own care, is like, is your insurance cover it, right, et cetera. So there's all these things in cancer care, right? There's standard of care, that stuff that's been around for a while or that everybody knows works well, right? There's off-label use, right? Which means that a drug was approved for one thing, but because of the time it would take to try and all these other things, like they haven't run all these other clinical studies. But one of the switches says it might be a good thing.
Probably going to work. So I had a patient, last week where cholangiocarcinoma, if you haven't heard that term before, it's basically like the biliary kind of system in your liver that kind of looks like liver cancer, kind of looks like pancreas cancer, but isn't. And it's very stubborn to treat. Well, in pancreatic cancer, they have this new, drug and they're using it. And I asked the company, I'm like, does it work in cholangio? And basically they kind of like make a face and, we have all this red tape. Let's just be honest. There's a lot of red tape, probably hopefully, let's say, put in all for, good purpose, like just for good reason.
Mhm.
But it's red tape nonetheless. It's become that. And I want to use that because I know this tumor behaves and has some of the same mutations as pancreatic, but I'm having trouble. So I'm having to go all the way up nationally to get it for my patient because it's not approved. It's not approved because somebody's like, well, we're not going to prove it yet. I mean, there's just that, again, there's that the sequence of events that happens to have an approval. And that's just the reality of it. But it becomes a whole different reality when it's your father, your spouse, or your child. And you're
Right.
like, so you're telling me it probably works. And I need this to actually, it could actually give extra time, significant, but I can't access it.
And then there's, clinical trials, which we all hear about. I mean, we talk about clinical trials, and I think we all learned over the last 3 years a whole lot about clinical trials. Nobody, in general understood before. So we're, I think, well-versed on that subject
Right.
now. But in cancer patients, only somewhere around the numbers between like 3 to 8% of cancer patients actually are able to participate in clinical trials if they want to. They were eligible to. And it's hard. And there's a lot of reasons, structural, scientific, et cetera. And then there's other ways. There's compassionate use, expanded access programs, right? Which are kind of when there's nothing for you, but there's a good reason. Like there's no data at all, but at least there's a reason to do it. And then there's even right to try, which is in some cases, like there's custom vaccines out there that people actually, frankly, just you can buy these technology from people.
And I want to talk about that for a second, because the trial thing, right? If you hear that term trial, it's like, I don't want someone to literally experiment on me and just see like, oh, we hope this works out, or does it going to make you sick or not?
Mhm.
And we know trials aren't that now, but there is merit to that statement, right? Trials originally, in general, at first, phase 1, what does that mean? It means like, is this going to kill, the subject or not? So they do this like, obviously at first, unfortunately, sorry, PETA, but like on animals, like they see like, is it toxic to where even that you could even handle the treatment? That's at phase 1. And so back in the day, decades ago, that's what we did with chemo. I mean, it's like you just basically give it just in doses to see if they could tolerate it. That was that barbaric thing that I think people kind of originally just automatically think about now. It's like, I want to see if it's compatible with human life, but that was that decades and decades and decades ago. And then when you have that chemotherapy, then in that phase 2 trial, what that means is like, all right, we know the dosing works. We know like it's not, toxic and doesn't, unfortunately kill people. I hate to use that term, but that the body's can handle it. Then the phase 2 is like, okay, but is it effective? And is it effective to a large enough degree to be able to justify those toxicities? So not the stuff that really like, makes you critical, but obviously things have toxicities. Is it enough? And we went from that to now, when you really fast forward to like 2020s, our trials now are not like that shotgun approach with like, let's give it poison, see if it works. We know our trials are like, we know this receptor works. We've been using this drug for 7 years and da. And then this is just a variation to that receptor, or this is something that we've studied for a really long time. Those are what we mean by trials now. It's, they've already been, we know they're safe, a very close, almost, sister, if not even closer to something we already use, but then we're trying to just be more precise. That's one big point. And the other point that I think is so important, right? This term data, like we were talking about, all this stuff, when you hear personalized care, what personalized means is when we're talking about that circuit board and those switches and which ones are flipped and which ones are not. And did you have surgery before in your gut, which would make you like more at risk for the gut toxicities? All of that, when you put all of that into a bag and don't just generalize it with the recommendations, and then you actually go into the house and look at the circuit board and look at the circuits, that is personalized and precision medicine. And that, when you said, well, how do we capture it? And how do we know, like, okay, we got this awesome thing that needs the series of binary switches to be A, B, B, A, no, binary code, sorry, 1, 0, 0, 1, 1. I'm with a very engineer guy, so I don't want to mess that up. But how do you apply that to knowing that sequence of like binary coding? That is what we mean by data. There's no way as a colon cancer patient, if you're not getting chemotherapy, and you want to know, you have that switch that right now looks, it's so effective. That switch, if you look in the fine print, it says silver, red, orange. We have drugs that say silver, red, orange. How in the world would I know that this drug that works really well, that you have that combination on your exact tumor type, unless I have your data? That's what data is. Like, and data, unfortunately, is a very broad word, right? Hillary Clinton days, our data got lost. That was very scary. That's data. We don't know. I'm not politically inclined at all, so I don't know what that means. But other people too, iPhones, do you want to share your data? So like, it's easy to group the term as like, well, I don't want them to have my data, my social security and my genetic footprint. It's more like, what is the data specifically we're interested in on the tumor type? What switches did it flip? And then all drugs require your own body's ability to process them in certain ways. Does it process at 90%? Does it process at 30%? We need to know that data so that we don't give you something that's either like too toxic, like your body can't handle this much and now it's making you sicker, or worse, well, not worse, but equally bad. We thought that, most people are about 50% on their processing ability, but you're 90, so you're only getting 10% of the drug. And therefore, when you progressed, it's not because it didn't work. It's because we didn't know that, you just happened to metabolize it quicker. It's like how people say like Advil doesn't do anything for me, or it does everything for me, or, all that stuff. That's those kind of abilities, those enzymes to be able to make stuff work when it's in.
You just did an incredible thing as I was listening to you talk about that. You took the concept of data and you took it into what I actually think spend most of my time worrying about is how does data become knowledge, right? And, as an oncologist, you have this incredible knowledge from all of the patients, like your experience, right? Everything you went to medical school and studied from your residency, your practice, right? And you're using that knowledge in real time. And so like part of the question is like, can we capture some of that knowledge? And then number two, can we make you more efficient? Like, this is something I wonder, like, I mean, let me ask you, like, how many patients might you see in one day, Sanjay? Like how many?
Yeah, 20, 4 or 5 days a week. And it's not just seeing them then. It's like, what happened since the last time I saw them in their
Right.
specific disease process? And how much do I want to whittle it down to see exactly in small sample trials of 80, does that one switch that they have that was irrelevant when I was in fellowship just 3 years ago, it was irrelevant. Now it is showing relevance. One, how the heck would I know that it is relevant, right? Mm-hmm. And two, like, how do I know that it's applicable to my patient? Like let's just be honest. I hope if oncologist hears this and not like, how could you say that? There's no way for any one individual. They don't have the bandwidth to be able to do that re-update in their like minds and efforts and energy to be able to just research everything on that specific tumor type for that one patient they saw that day.
Right. So one of the concepts I've been talking with people about this for like well over, oh gosh, I didn't date myself. It's been at least 15 years that this idea has been circulating. I think broadly what did a lot is this idea of continuous learning, right? Uh-huh. Which you're doing every day in your practice, right? Like every day you try things, you work with patients, you learn things. I've been doing it my whole career. Like every day I try something new and we're all doing this. But like, how does a system learn? Like, how do we all collectively learn together in like real time? So that, which answers that question, right? Again, that fundamental question of like, what did people like me do and did it work or not? That's actually the knowledge, right? So number one, you got to capture all this data, right? You got to put the data into a place where it's like interoperable, which has been, 10, 15 years in the making in healthcare, just getting people's data into the right format. And there's still an incredible amount of, we spend a lot of time translating physicians' notes, right? So doctors write, you write notes on your patients. I think this is going on. In that is like your actual opinion. That's not written as like a 1 or 0. It's just the words you're using to describe what's going on. So how do we turn that into something like a machine could use, right?
Right.
So
I mean, and one example of that, it's, and I'm sure other people have it, and I hope my friends aren't, whatever about this, but when we got out of fellowship, like, I made a group thread in WhatsApp, right? Because we all like kind of have our specialty since we got into practice. And we have one buddy that works at the VA, prostate cancer, GU, men's health, and all these things. And so what we're doing as a very simple term, almost offensive for what you've created, but we have a little group where our one, oncologist friend that we graduated is seeing a lot of the most novel stuff in just men's cancers, right? GU, bladder, like prostate, all these things. And then we have somebody else that's doing breast. We have somebody else that's doing malignant heme. So we have this little mini query on being able to say like, I noticed this mutation right now. There's no standard guidelines, but have you seen anything, whatever? And then they have that little experience.
So there's a really important piece here. How do you get it all in the same place? And there's an incredible role here, right? For patients, right?
Right.
Patients. And I always tell this, this again came from my own experience, right? When I started working directly with the patients and like, that was myself and it was my family members, right? I'm like, what can I do as a patient? And that's a really different way of thinking about healthcare from like 20, 30 years ago. You were like, you went to your doctor and like whatever your doctors or the system said just happened to you. But now patients can like, they can be activated. They can do their own things. They can be empowered. And one of the greatest powers that a patient has, I always think of this as incredible power, is to access their data. And I don't think many patients realize this, but they are really the sole keepers of the data that exists for themselves. So what I'm specifically talking about is HIPAA, which is our privacy law, right?
Right.
So One of the reasons it's been so hard to share information is because it needs to stay private. And there's lots of great reason to keep data private, right? Like I don't want my data out there to be used for bad things, right?
Right.
But there wasn't for a long time and hasn't been anything good to do with it either. So I just wanted to keep it safe. And we built laws and structures, right, as a society to make sure that happens. And the person who holds the key to directing the use of that data, but has never really realized this, and this has just changed legally even over the last 3 or 4 years, is patients. Patients have this key that says, yeah, I want my data private, but I also want you to use my data to help make a decision for me. Right. And I want to share my data with other people because I want them to learn from the decision that I make. The difference between protecting your data and actually using your data on your own behalf. So I can now use my data. This is what we've been trying to do at xCures. Give you some way to use your data and contribute it at the same time. So it's not just research. You know, we're talking a little bit about research, like, oh, I'm going to help some other people because I feel like it's a good thing to do. It's I'm going to help myself and I'm going to help others. And it goes right back to something you were talking about earlier when we were talking about off-label therapies.
Right.
We were saying like, hey, in this cancer, it's been approved for A, but it hasn't been approved for B yet. Why? Well, because nobody's gone off and run this clinical trial, which is going to cost millions of dollars and take another 3 to 4 years, right? But there's no like logical reason why we don't think B should work. We just haven't done that. We can short circuit that entire, and this is where technology is going to take place. And the way you short circuit is, I just want to see if it works or not. So if there are people where we think it should work and their physicians think it's probably the best thing for them to try, which is like nobody knows the right answer here. So let's let the people with the experience, the knowledge, the doctors decide and, you know, understand that access. But then let's have everybody share, right? Then you'll be like, oh, we all
accelerates. It basically just like literally just accelerates the process and all that red tape we talked about and all that time. It's just like an acceleration so that, you know, God forbid if we get older and all that stuff, like the data took it was way quicker to be able to test the effectivity than just looking in the dark and hoping it falls in your lap.
Or having a very specific research program, right? And those things aren't bad, by the way. The clinical trial is incredibly important. They give you a very high degree of confidence, right? But they also make you try one experiment at a time, right? So, and
you want to eliminate all variables, make sure there's nothing else that's causing it. Right. I want to talk about for a second, like that's why cancer is so challenging. If you're listening to this, you're like, dude, I just don't get it. Like it can't be that hard. What makes it so challenging? Aside all the switches, the illustrations, everything we talked about or going to talk about, this is earlier in the podcast, is all of the things that are in that cancer cell are things your own normal cells can make and have made because that cancer itself was one of your normal cells, right? That's what people don't understand. It's like, or I think have trouble understanding. It's not something you caught. It's not like a foreign body. Your cancer cell was one of your regular cells that was doing everything it was supposed to for 30 years, 40 years, 50 years. And that's why cancer just shoots up, you know, super high after like 50, 60, 70, because over time, as it kind of followed what it was supposed to. And every time it carbon copies its DNA and makes a new cell, and it knows when it's supposed to die, and it keeps doing that. Little mutations go undetected, and switches that are supposed to turn off don't turn off anymore. And that is cancer. So now it's all of a sudden growing, but by all accounts, it's got all the same properties that all your other cancer cells, all your regular cells did. So it's not like a silver bullet. It's like, well, we know this is a cancer and it's showing this and nothing else does, so attack it. They all use stuff, mechanisms that your normal cells do. And then we were learning is way more complicated than just that one switch. But even if you attack, because if we identify that switch and we're high-fiving and oh my gosh, when we start treatment, after 8 months, the cancer disappears, what happens? After a couple of months, something else comes up. Why? Because that cancer got so smart in its replication and said, I don't need that switch anymore. I found another way. I found a loophole. And it keeps finding these loopholes. And then we only can attack the loopholes that we know.
Sanjay, I am so excited that you're going to be hosting this podcast. This series is just going to, I think, help so many people. Your knowledge, your insight, right? And all of those technology you talked about are all things people need to know about. And that's what, you know, we have a company been trying to share that, help people do that. Thank you.
Thank you. Let's tell them how this happened, right? Like you actually made my life a lot easier in practice because that stress that I have at 2 a.m. waking up and saying, is there something else? Do I need to go from the bottom up all over again on cholangiocarcinoma to see if there's more targets? Do I need to reorder the molecular targeting, panel to see if something's come out since I ordered it 7 months ago? It didn't even know to test for it, and now it does. And am I sure that this is really it and there's no more treatment options? you have alleviated that. And we want to bring that to not just like, the mental alleviation to all oncologists, but to families to say, you should want to ask again and are allowed to ask again, but is it really everything? Can I trust my oncologist? Not because they're not working hard, but because of the limits of access of knowledge. And that's what, like, in this case, xCures does. It congregates all of those things that exist and then tells you and the patient, here are all the things that are relevant to your cancer. Here are all the things that are guidelines and that you should have, ideally gotten or had some sequence of these that are approved. And here are all the things that are being studied right now and maybe showing promise and may not be. And that's like, it's a peace of mind for an oncologist. It's a huge time saver. I can save more time with my kids. And obviously, like, families just feel good. They can say, at least I know that everything that exists in the world today, I checked to see if it was applicable to me or not. And then you can have that, not closure, but in your mind say, okay, now we're going to focus on quality of life and other things.
There's confidence, right? You want to know that you did the right thing. So yeah, I mean, we have been focused on how do we help you use your data, do that securely in a way you can have confidence in your privacy, but also use your own data and use it with your doctors, right? And your doctor can use your data.
Right.
And then how do we add this decision support, right? And AI on top of it. And there's no simple answer, as we talked about, but there are some things that are clearly better to try than others, right? And if you looked at any one of these things on your own individually, you'd be like, oh yeah, that makes a lot of sense. But who has the time to go search 10,000 things every single time, 20 times a day? You can't do it. So just these tools. And as we talked about, if we do this right, and we communicate, and your core skills of knowledge, communication, and getting people to understand what's going on, and then we get people involved, and we all work together and share and collaborate. This is like
right.
Collaboration is with everybody. We're going to move the needle fast. We're going to do what hasn't been done, right? Which is really figure out how to beat cancer, right? And the only way I can imagine doing that, the only way is through this collaboration mechanism, communication, education, and collaboration.
I'm so glad you came on. I'm so glad you're offering these things. We're going to obviously have links if this like hit home with you and like, oh, I need that, or I want to learn more about that. I want to help, you're going to get all that information. And then we're going to have more series with just like big players that are really trying to move that needle as well. And then we get all on the same team, and you're going to be sitting in a room, if you're listening to this, with these people. And then you're going to be the most interesting person at the bar, assuming it's, intellectual conversation rather than just whatever. Or you'd be interesting either way. It worked for me when I was in college. I love sharing these kind of things. Thank you, Mika, and I look really forward to it. And y'all can find additional information in the links. Again, this is Dr. Sanjay Juneja, the Onc Doc on social media, and we appreciate your desire for education. You've made it through this video, and I am super stoked. Hopefully you feel a lot more knowledgeable and even somewhat comfortable about the crazy world of cancer. If you did, like, comment, but especially just share, if nothing else, to get this information out so that hopefully people are less intimidated by something that's as scary as cancer would be a big win. And we look forward to seeing you here next time.